So we talked about the history of cloud computing. We talked about some key dates in the history of cloud computing. We defined cloud. But now it's time to talk about the history of AWS. It's important to also understand and learn about the history of the technology that you are looking to master. Now over here on the right, if you didn't know, this is Amazon's chief, Jeff Bezos. He's the CEO, right? Now in 2002, as we spoke about earlier, Amazon Web Services was born. Now remember, Amazon Web Services was born simply as a method of delivering information to partners via web services. It also offered some programmatic and development support, but it was kind of only that. Now in 2006, Jeff Bezos took the stage at MIT's Engineering Technologies Conference to talk about two cloud computing products, and those two cloud computing products were EC2 and S3. And he also talked about the ambitions of the company for having them and why they had them. EC2 was developed first and foremost for Amazon's internal infrastructure. Now, Amazon Web Services came about because of a need. It didn't come about because Amazon had this, grand scheme of, hey, we're going to build this and then we're going to sell it and we're going to get into the cloud game. Again, they didn't know that they were getting into the cloud game. They had a need to scale out Amazon's infrastructure worldwide and to give developers access to this infrastructure centrally. So that's where the idea came from. EC2, S3, all of these services were developed first and foremost to support Amazon's internal infrastructure and the expansion of the company. Now, this is an interesting quote from Jeff Bezos that I thought I'd mention here. Now think about this quote for a second and put that in context with cloud computing. Put that in context with all the things that we've been talking about. When you're looking at cloud computing is a way that helps organizations focus on the business, on what they do best, and it abstracts everything else. So if we're taking the case of Amazon, what is cloud computing doing for Amazon? Well, guess what? It is abstracting all of the IT that needs to happen in the background in order for them to focus on what? Well, on their e-commerce platform, right? And that's why Jeff Bezos says here, there's a hidden Amazon underneath Amazon.com, which is what you see, what you view, which is the e-commerce website, the platform. There's another Amazon. That's Amazon Web Services. That's all the cloud infrastructure. That's EC2. That's S3. That's all of the stuff that they have to do behind the scenes in order to present an e-commerce platform that can scale worldwide. Now, guess what? What they've done is they've taken that know-how, that knowledge that they used to scale Amazon.com worldwide and to give access to developers and etc., and commercialized it. And that's a brilliant business proposition. That's very daring for a company the size of Amazon and the focus and the profitability of Amazon to take an undertaking essentially outside of their forte, outside of what they know how to do, which is to sell books and stuff online, right? But underneath that, they also learned how to build this massive infrastructure, and the idea, well, why don't we capitalize on it? An infrastructure service for the world. That's a really cool quote. Now, the picture on the right is of that of Chris Pinkham. Chris Pinkham, back in the early 2000s, was an engineer that worked at Amazon in charge of their global infrastructure. This idea of an infrastructure service for the world was essentially started in his mind. Back in 2003, they started to build an infrastructure. They started trying to build an infrastructure service for the world. Again, the idea here was they wanted to develop a service that would not only deal with Amazon's infrastructure, but also help developers. So you have developers spread out across the world. You need an infrastructure that can support customers across the world. Amazon doesn't just sell for customers in the United States. It sells for customers in Europe, in South America, in Africa, in Asia, and Australia, across the world. So their infrastructure needed to be agile and elastic enough to support basically development from everywhere and customers from everywhere. So the idea was not just to develop an infrastructure that can support Amazon's business, as in servers to support the e-store, for instance, but also help developers get access to the resources they need, be able to develop faster and quicker on this infrastructure. Pinkham later pitched this idea to Jeff Bezos, again, the CEO of Amazon. And the idea intrigued him. He asked him to write a short paper about this idea, and he did. He did with the help of another Amazon engineer, Benjamin Black, and they wrote a short paper with regards to what this could look like. And Jeff Bezos liked it so much that he asked them to write an extensive and more detailed paper on this. And this is where it all started. And from there, the idea was they were going to develop this massive infrastructure and they were going to offer it with low margins. Why low margins? Well, in order to not encourage competitors to get into this space, to discourage them basically. They were offering it at low margins. Again, the competitors now had to think of, well, if we wanted to compete, we have to build this massive infrastructure, and the margins were so small. So again, discouraging the competitors was the idea behind this, while also providing lock-in for a lot of customers. The customers that that were on this platform were going to stay there for a long time. So that was kind of the premise. And Jeff Bezos then took this idea and wrapped around it this aggressive expansion. And this is what, if you look at the history of Amazon and how quickly they expanded and how quickly they scaled Amazon Web Services from 2005 and 2006 and on, it's truly scary when you look at how large this infrastructure is today. Another interesting quote that I found there from Werner Vogels, is Amazon's CTO, is from experience, we knew that the cost of maintaining a reliable, scalable infrastructure in a traditional multi-data center model could be as high as 70%, both in time and in effort, and required significant investment of intellectual capital to sustain over a longer period of time. What should you make out of this quote? Well, the idea here, what I want you to do is take this quote and apply it to your own data center. Apply it to your own business. Again, I want you to step outside of your IT persona for a second and think like a businessman. Understand the cost of maintaining a data center, multiple data centers, traditional multiple data centers. Again, when you're looking at this quote, I want you to see keywords, things that stand out, things that are important to you. So again, from experience, we knew that the cost, keyword, of maintaining, keyword, reliable, keyword, scalable infrastructure, keyword, in a traditional multi-data center model, another keyword, could be as high as 70%. Keyword, again, 70%. So the idea here was they were looking for a more efficient way to save on time and on an effort, and required significant investment. So they were looking for a way to reduce the time, the effort, and the investment in intellectual capital to sustain this over a period of time. So if it was as high as 70%, they needed to find an alternative way. This is why if the cloud has served Amazon in order to lower, again, the time and the effort, the significant investment, etc., if it served them, then it would probably serve you as well. Because they've learned that through experience. This is the takeaway from this quote. The importance of this quote is Amazon is eating basically its own dog food. They realized that this was expensive and they needed to find an alternative and came up with Amazon Web Services, applied it, and they're using it, which is what makes Amazon Web Services so valuable and why you should be looking at it. Because they've gone through this. There's a use case in them. They put their money where their mouth is. They actually invested. They did it, and now they commercialized it, but they're still using it. They have a business on top of it, which is why the cloud should always be taken seriously. And since we brought up cost, and since we brought up traditional multi-data center and investments and intellectual capital, etc., let's take a look at what it takes to run a data center. And I'm just going to give you an idea of some of the components in a data center. I'm sure you'll find one or more that I don't have on this list, but all of these are components that are required for an on-premises data center, right? You need security, you need cooling, you need connectivity, you need servers, you need storage, you need intellectual capital expertise, you need networking hardware, you need cabling, you need facilities. All of those you need. And guess what? You need intellectual capital expertise in almost every one of them, right? So if you think about it, today in your environment, you probably have a team that deals with servers and operating systems. You probably have another team that deals with networking. Keep in mind those circles as I'm talking. You probably have another team that deals with storage. You probably have another team that deals with facilities. That falls, cabling might fall under that, cooling might fall under that, maybe connectivity could fall under that, or it could fall under networking. You have another team definitely that deals with security. So guess what? These are silos within your environment, and every one of those silos requires intellectual capital expertise to make it run. Now, realistically, again, step outside of your IT persona for a second and tell me, what does this bring value to the business? Yes, they're important, but they're very expensive. And as you grow your data centers over time, maintaining these silos of intellectual capital where you need these folks and then you need another set of folks to do applications and operating systems. Sometimes they're the same, sometimes they're not. It becomes very, very frustrating. And scaling this and being able to build those repeatable processes, putting in these automation systems, and having the documentation, all of this becomes almost a business within a business and becomes very expensive. So all of these on-premises components, yes, they've worked for the last 30 years, but realize that the world wasn't moving at the speed that it is today. Realize that globalization and the fact that we're doing business worldwide, not just Amazon, every business today is doing business worldwide, which means you have to be able to scale to the size of Amazon without necessarily having the deep pockets that Amazon has. So all of these are components that you're familiar with. All of these are on-premises components that you need in order to build data centers. So let's talk about before and let's talk about after. All of the components that I just showed you, you can go out and buy individually, right? You can go out and buy all of these components and put this beautiful bike together yourself. It will take you time. It will take you longer than just going to the store, buying the bike, and just starting to ride it. So if you are someone who wants to get in shape, or if you're an athlete that wants to, I don't know, maybe you're trying to compete and you need a bike, well, you have two options. If you want to compete or if you want to start training tomorrow morning or even today, you can go to the store and buy a bike. This bike is completely built. It's built to specs by machines maybe, etc. And it's ready. You just go buy it and you start riding it. Now, alternatively, you can buy a kit that has all of the components to make up the bike. Maybe you want different brakes on this bike. Maybe you want different colors for the handles. The seat should be different. Maybe the tires should be different. Maybe you just want to customize, this great looking bike and you just want to build it yourself. Sure, you can buy all of those components. But unless you're a bike builder, it will most likely take you hours, if not days, to put this bike together. So realistically, if your objective, and here we're going to take this example, if your business objective is to train for a marathon, then you probably want to go out and buy the bike and start practicing sooner rather than later. If your objective is to learn how to build a bike, then maybe you should go out and buy all of these components and build the bike yourself. And I can give you multiple examples of that, right? So for my video training, I can either go buy a computer and a server and start recording with a microphone, or I can try to build my own computer by buying the motherboard, the RAM, the video card, etc., putting it together, installing the operating system. It's just a matter of priorities. How fast do you want to start on the more important thing in your life, the objective? If your objective is to train for the marathon, then you probably want to go out and buy a bike immediately, right away, now. If your objective is to learn how to build a bike, well, maybe you go out and buy a kit. If your objective is to run a marathon, but you're not really in a hurry and you want to build a bike because you think that it'll be more reliable and faster, then by all means, go out and buy it. Again, you're probably going to maybe not have all the tools required. You're definitely not going to have all the know-how, especially if it's a bike that you've never built before. But you get the idea before and after. And it's the same thing with data centers and Amazon. Sure, we've been building data centers for the last 20 or 30 years, and we've gotten really good at it. Now what Amazon is offering is, look, instead of you wasting your time on facilities and worrying about all of this stuff, we are going to do it on a massive scale. We're going to put automation in there, and I'll show you a little bit later on some really cool stuff. And we're essentially going to become masters at this. Why don't you focus on the stuff that makes your business run? Why don't you focus on how you can become more profitable quicker? Now, that doesn't mean that you're not going to be building servers, except you're not going to be racking, stacking, cabling, putting memory in, testing the memory. All of that is abstracted. Focus on bringing up that virtual server, put the right application, hand it over to the application server people so that we can get to the point where we're making money faster. Because in today's world, those that make money faster are going to always be ahead. That's the idea behind this bike that I wanted to share with you. Now, understanding infrastructure as a service. There are different components that make up infrastructure as a service. You start from the very bottom, right, with a physical infrastructure. You then lay a virtual infrastructure on top of it, vSphere, Hyper-V, Xen server, KVM, whatever it is. A management layer like Microsoft System Center, Virtual Machine Manager, vCenter, whatever it is that you're using from a management layer perspective. And then you start to go into these different components, right? You start to build chargeback. You start to worry about capacity management. You start to worry about change management, policy-based approaches. You have lifecycle management. You have performance optimizations. You have the ability to do identity management. All of these components that you have here are infrastructure as a service. You get into service catalogs. Service catalogs is essentially what you're offering your users so that they can consume from that self-service portal. They can go in and say, you know what, I want a virtual machine with 3 GB of memory and 6 CPUs. If you have a service catalog that fits that, well, they can consume it immediately. If you don't, then they would have to pick one of the other services that you have. Maybe you have one that has 8 gig of memory or 6 gig of memory and 4 CPUs. Maybe they'll consume that. Maybe you have a service with the entire application stack built, a SQL server, for instance. Maybe you've taken it one step further and you're delivering the entire 3-tier application, which is a web server, application server, and a backend data server, database server that they can deploy. So you're able to pre-provision a lot of those and they're able to consume them. Now, what happens when you're providing the service catalog of services? If they choose one of your pre-configured services, and they click, I want this, and it goes through all the right workflows and approval process, it will automatically be provisioned in the backend. Now, how do you automatically provision something in the backend? Well, again, we talked earlier about a system and about automation. And in order to have a system and in order to have automation, you need to have identifiable, repeatable processes that you then build a service out of. When you've identified the processes required to create a server, then you can automate that entire workflow, that entire process. Once you've automated that entire workflow and that entire process, you can add a service which then triggers that automation. It'll create, provision the server, create the compute, the storage, the networking, add it to the right network, install the operating system, and if required, install SQL Server, for example, on it and an application on it. So it depends on the complexity of the service. It also puts it on the right storage tier depending on how fast it is. Maybe it'll make it participate in disaster recovery so that it's being replicated. There's a million and one ways how you can go with infrastructure as a service. But the idea behind infrastructure as a service, what I'm trying to leave you with, a lot of customers think that, hey, we have vSphere installed, we have virtualization, so I have a private cloud. No, you don't. The idea behind the private cloud is the automation of repeatable processes and taking into account things like chargebacks or showback. Maybe your accounting system doesn't afford chargeback. You can't create an entry in your accounting system for chargeback. But you certainly can do something for showback, where at least you're showing the different departments how much they're consuming from services. When you're able to do all of these components that I have on screen, then you can say I have an on-premises private cloud. The cloud is about automation, is about having a repeatable system that you can use without manual intervention, so that if you want to give it to the business, your marketing department needs to run a campaign. If you have the right components in the service catalog, they visit the self-service portal, they provision their needs. You don't have to manually intervene. You don't have to open help desk tickets and wait for weeks until, or days or weeks until they've created those servers and handed them to you. They're able to take control because you've automated, you've built that level of do-it-yourself, that level of automation within the environment. So giving you an understanding of infrastructure as a service, why it's important, what are the components that go into it, hopefully will clarify how much Amazon Web Services is putting into AWS, how much thought process has gone into it. And when we start to look at the management console and AWS and the guts of AWS, you'll be able to appreciate all of this stuff more, because you can do everything that you see on screen from Amazon Web Services. All of this stuff. You can provision virtual machines, you can install applications, you can create service catalog, you can do all of this stuff. So the idea behind, if I'm able to do all of this stuff with Amazon Web Services, How much have they spent in terms of money and effort in order to build that platform so that I can consume it? And do I need to spend that much effort to do something on premises? Well, the answer is, well, it depends. It depends on, there are some products out there that will allow you to create Amazon infrastructure as a service like clouds on premises. But you still have to configure them. It's still a lot of work, but it's doable. It's not going to be as difficult as you need to, write Python codes to the storage in order to provision it. A lot of that, again, is being created for you so that you can focus on the automation of your particular process that are relevant to your business. But it's important to show you this particular figure because I wanted you to be aware of the different components that are involved with infrastructure as a service. Let's talk a little bit about do-it-yourself, DIY, versus AWS. We've talked a lot about it, but I wanted to give you a visual of, again, what it is like to do it yourself versus AWS. So with do-it-yourself, you have the concept of scale up. What does that mean? Well, you make a large purchase today of 100 servers, and that might serve you for, let's say, 6 months or a year. And then you make an acquisition or a merger, or something happens where you need more capacity. So what do you do? Well, the business tells you that, we're acquiring another company and that other company is maybe half of our size. Well, half of our size means I might need another 50 servers. So what do you do automatically? You over provision, which means if you need 50 servers, you're most likely going to go out and buy 100 servers. So you've just added another 100 servers for a total of 200 servers, and so on and so forth. With AWS, you don't need to do that. The Elastic service allows you to scale up and scale down as you need. So if you need 100 servers today, you can scale up to 100 server. If tomorrow you don't need these 100 servers and all you need is 50 servers, you scale down to 50 servers. Now just imagine the cost savings in terms of capital expenditure that you've just saved between the do-it-yourself method and AWS, and it's on the fly. It's not, it takes weeks, it's immediately you can take advantage of these types of services. With do-it-yourself, with a traditional on-premises data center without cloud, you have to assume reliable infrastructure. You're building your infrastructure in a way where the application is assuming reliable infrastructure. You're doing clustering at the operating system level. You're replicating your SANs. You have failover capabilities on the network. I mean, you are building a reliable infrastructure. Guess what? With Amazon Web Services, with cloud in general, expect infrastructure failure. What are you, crazy, Eli? No, I'm not crazy. They are giving you a platform and they're telling you it is going to fail. Build your applications, build your infrastructure around the concept that it's going to fail. Now, if you step back and think about it for a second, which option would you prefer? Now, obviously, for the longest time, I was on the left, right? I would prefer to build and assume a reliable infrastructure. But as you start to think about it, if you change your mindset and expect infrastructure failures, you can then build your applications in a way to expect the infrastructure failure and kind of get over it. And there are ways of doing that, and we'll talk a little bit later on design principles, on how you can, expect an infrastructure failure and, again, react to it. But those are the two differences there. You have diverse technical expertise versus expertise that's focused on applications. We talked about this a little bit earlier. Diverse technical expertise means that there are different silos within your environment. You have a networking team, a storage team, a services team, servers team, a facilities team, etc. So you need technical expertise, and you have application teams. You have all of these teams with diverse technical expertise. With AWS, let's take away a large chunk of that, focus on your applications. That doesn't mean you don't need administrators anymore. You do. That doesn't mean you don't need networking folks anymore. You do. But those networking folks are now not just focused on networking. Why? Well, because they're not managing the hardware. They just need to be able to configure the networking the way you want it. So they should be able to also manage the servers, and they should be able to also manage the storage. So now that person that was a technical expert in just one silo can take on more because of the simplification. So focus on the applications mean we're going to abstract all the complexity of the physical hardware. You focus on the virtual and the logical pieces and focus on your applications, focus on what's going to make your business money. In a do-it-yourself, the applications are unaware of the infrastructure versus with AWS, the application could could be aware of the infrastructure based on how you've developed it. And what do I mean by that? So let me kind of dig a little deeper into that. If you're installing an application on top of Microsoft Server, right, a Windows Server, the application doesn't know if you've clustered that server. The operating system knows that it's clustered, but the application doesn't. The application is expecting that infrastructure to be up and running. If the infrastructure fails, the application fails automatically. So the application is unaware. It can't see it. It can't make any calls to the infrastructure. It can't request more capacity, nothing. All the application can do is perform poorly, and as a result, you would have to figure out, why is this application performing poorly? Does it need more RAM? Does it need more CPU? What's causing that slowness? And then you address it that way. With AWS and with cloud in general, applications can be aware of infrastructure depending on how they've been developed, which means if you're developing your application properly against the cloud, the application can be aware of the infrastructure and can make requests, can make calls to the infrastructure to provision additional resources when it needs them. So if the application requires more web servers because the load went up, the application can make a request to provision more web servers. If it requires more database servers or services, it can make that request as well. So the application is in tune, it's connected to the infrastructure and can manipulate the infrastructure to a large degree. Those are differences. Now again, the application would have to be developed that way. You're not going to take a traditional client-server application and make it aware of the infrastructure. What you can do is take a traditional client-server application and put some automation around it, which means if the application hits 80% CPU utilization, I want you to automatically provision 3 more web servers. You can do stuff like that. But true service-oriented architectures, SOAs, are built with the application controlling the infrastructure instead of the application unaware of the infrastructure and just expecting it to be reliable. With do-it-yourself, you have high upfront costs. Again, we go back to that same example. You buy 100 servers, but your need is just 50 servers. And then when you cross that boundary of 100 servers, you buy another 100 servers when your need is just 50 servers additional. You have to buy all the networking and storage and facilities that, again, correspond to this server purchase that you just made. So all of these are high upfront costs. With AWS, it's usage-based costs, right? If you need 50 servers, you use 50 servers, you pay for 50 servers. You don't need 50 servers, you don't pay for them. So it's pay per use as opposed to those high upfront costs. You have design, build, operate, and support. That's for the traditional do-it-yourself. You have to do all of those. With AWS, they've taken away a lot of that complexity, right? So you need limited knowledge of the AWS environment. But you don't really need to know how they've configured their storage. You need to know how you can leverage the storage. You need to know how many tiers of storage they have so that if the application requires high-speed storage, you know where to put it. But you don't really need to know the Python code that they're using, for example, for storage. You don't need to know what type of storage they have. Is it EMC or Hitachi or NetApp or whatever? You don't need to know all that stuff. You don't need to know how they're replicating it. You just need to know that the data is being replicated. Now, you also have the concept of shared support. Support is never going to be a 100% Amazon or 100% you in a cloud. It's going to be shared because there's a portion that's Amazon is responsible for, and we'll talk about that later, and there's a portion that you're responsible for. So there's that shared support model that's going on there as well. Sum it up for us. Okay, so we started with the AWS history. We talked about how it got started. We talked about the fact that Jeff Bezos, again, introduced it in 2006 at MIT's engineering conference. We talked about the fact that an infrastructure service for the world essentially started in the head of Chris Pinkham for the reasons of AWS, but also to support developers. We talked about understanding infrastructure as a service and all the components that go into infrastructure as a service and why infrastructure as a service is different than just virtualized environments and what you would need to understand and know in order to build an environment like an infrastructure as a service. We talked about the difference between do-it-yourself versus how Amazon Web Services does it, and the fact that you're scaling up versus elastic, the applications unaware of the infrastructure versus application that are aware of infrastructure. We talked about the diverse technical expertise that you need versus limited technical expertise, all the components of do-it-yourself versus AWS. And I'm sure you guys have gotten to the conclusion now that I'm obviously a fan of cloud. But don't forget, I've been also in this industry for the last 16 and 17 years. I've gone through the do-it-yourself. I've built, I've racked, I've stacked, I've done all of this. So I have an appreciation for the cloud, not because it's the next coolest thing, but because it makes sense. Now, does it make sense for everybody? Does it make sense in all cases? Absolutely not. There's always going to be a case for on-premises. But the idea is not to be rigid, not to be stuck in, okay, it's either this or that, to be flexible, to be fluid, to understand that if there's a better way, you should use that better way. Don't try to force something. Finally, I hope this module was very informative for you, and I'd like to thank you for viewing.